Okay, so let me do problem number 1. Find the square roots of the following number. And so I want to find the square root, both of them, of 49. Well, the square root of 49 is equal to 7. Therefore, we have plus or minus 7. Let me do problem number 2. Simplify the following expression. So the cube of a negative quantity is negative. The cube of the cube root of any quantity, even negative, will be that same quantity, negative 343. So the cube gets rid of the cube root, and we get a negative 343. Minus a negative 343 is just a positive 343. 3. Identify the number as rational, irrational, or non-real. Well, since 16 is not a perfect square, then this will be an irrational number. Identify the number as rational, irrational, or non-real. Since 1 over 16 is a perfect square, then then the square root of 1 over 16 will be rational. So negative radical 1 over 16 will be rational. Use the product rule for radicals to find the following product. Well, the square root of y squared is just y, and the square root of 7 is just the square root of 7. And that is your answer. The cube root of 243 is just equal to, well, let's write 243 as the product of two numbers, one of which is a perfect square. So 27 times 9 is 243. The cube root of 27 is 3. And so I get 3 radical 9. Let me do problem number 7. The square root of 8 times the square root of 50. Well, actually, I would probably accept it. Even if you just wrote y, I would probably just still accept it as y radical 7. Even though you should have the square root, you should have the absolute value, I would still accept it with just without the absolute value. Square root of 8 times square root of 50. Well, 8 times 50 is 400. The square root of 400 is 20. And that is your answer. Let me do problem number 8. And so the square root of 80 divided by 5. Well, 80 divided by 5 is 16. And the square root of 16 is 4. Let me do problem number 9. And so this is the same as the square root of 36 over 7 times the square root of 3 over 77 is the same as, well, the square root of 36 times 3 over. Well, notice that 7 times 77 is going to be something, but 77 is just 7 times 11. So I can write 7 times 77 as 49 times 11. And the square root of 36 is 6. The square root of 49 is 7. And I'm done. But suppose I wanted to rationalize the denominator. then I could multiply and divide by the square root of 11. In which case I get 3 times 11 is 33. Radical 11 times radical 11 is 11 times 7 is 77. And that is your answer. 2a squared b cubed over cube root of 125, 5, cube root of a cubed, a, cube root of b cubed, b, a squared divided by a is a, b squared divided by b cubed divided by b is b squared. And so I get 2a b squared over 5. (11) The square root of x squared minus 8x plus 16. Well, the radicand is just a perfect square trinomial. And so by the special product formula, I have that x squared minus 8x plus 16 is just x minus 4 quantity squared. And the square root of x minus 4 quantity squared is just x minus 4 in absolute value. And there I would really require that you would write the absolute value. Let me do problem number 12. And so, right. So in this case, since you'd have to assume that x is greater than or equal to 4 in order to not have the absolute value, I would really require you to put in the absolute value because, that's not a usual condition that we require x to be greater than or equal to 4. So then, yeah, for problem number 11, I would require you to have the absolute value. So 8 radical 13 minus 5 radical 13 is 3 radical 13. Okay. 2 radical 7 minus 6 radical 343 is the same as 2 radical 7 minus 6. I can write 343 as 49 times 7. And the square root of 49 is just 7. And so, this is just equal to 6 times 7 is 42. So 2 minus 42 is a negative 40 radical 7. Okay. Problem number 14. And so this is equal to the cube root of 8 is 2. Cube root of x cubed is x, radical 2, minus, let me write 54 as 27 times 2. The cube root of 27 is 3. The cube root of x to the 6 is x squared. And so I have here in common a x squared. Oh no, that's an x. That's just an x. That's not a cube there. That's a cube root. Sorry. So I have in common an x and a cube root of 2. And after I factor that out, I have 2 minus 3x. And so that is simplified as much as possible. The 1024 to the 1/5 power is the same as the fifth root of 1024, which is just equal to 4. Maybe I'll write it up here. Everything is to the power of 1/3. So that's right, is a big cube root. 3 times 9 is 27. X squared times x is x cubed. Y times y squared is y cubed. And you have this to the 2/3 power. So if I square everything inside the parentheses, that's just saying that the rest of that's going to be under the cube root. So I have here x squared, y to the 4th. And so this is equal to, actually I could actually just have moved it down here, I guess. Because I'm not using as much space as I thought. So this is equal to the cube root of, well, I can cancel this. So x cubed divided by x squared is x. Y to the 4th divided by y cubed is just y. The cube root of 27 is 3 times, well, I can write this as cube root of x over cube root of y. And well, I'd be done, but maybe, here, maybe put the 3 there. But maybe what I want to do is write it to rationalize the denominator. So if I rationalize the denominator, I'll multiply and divide by the cube root of y squared. And so if I do that, I get 3, maybe I do need the space, but 3 cube root, I guess I'll return this back up to the higher place. I had it before. Okay, and so this is equal to 3 cube root of x y squared all over cube root of y cubed, but cube root of y cubed is just y. And that is your answer. Cube root of x cubed minus 15x squared plus 75x minus 125. Well, x cubed minus 15x squared plus 75x minus 125, that's just a perfect cube trinomial. So this is just by the special product formula. X cubed minus 3 times x squared times 5, 15x squared, plus 3 times x times 5 squared, 75x, minus 5 cubed, 125. The cube gets rid of the cube root, and you just have x minus 5. And since it's an odd index, you do not need to have a absolute value. Well, it's wrong if you have an absolute value because it's a odd index. Next, rationalize the denominator. So I have 1, 3. I need 3 more 3s. I have 3 more 3s. And so let's multiply and divide by the 4th root of 27. And so this is equal to the fourth 2 times. Oops, let me write that there. This is equal to 2 times the fourth root of 27 over 3 times 27, 81. The fourth root of 81 is 3. And that is your answer. Okay, I'll probably have to insert a page here. Oops, don't do that. Let me put it here. Okay, so French. Okay, so yes, all right. Okay, so let me do this. So this is problem. I don't think I have enough room for 19. So I'll do 19 down here. Rationalize the denominator. So I'll take the square root of 7 plus 4 over 3 radical 7 minus 3. Minus radical 3. So let me rationalize the denominator. So let me multiply and divide by the conjugate of the denominator, 3 radical 7 plus radical 3. And so I get, well, I can multiply this out. Radical 7 times 3 radical 7 is 3 times 7. Radical 7 times radical 3 is radical 21. 4 times 3 radical 7, well, 4 times 3 is 12, radical 7. 4 times radical 3 is 4 radical 3 by the special product formula. The product of the sum and difference of two terms is the difference of their squares. 3 times 3 is 9. Radical 7 times radical 7 is 7. Positive times negative is negative. Radical 3 times radical 3 is 3. And so I get 21 plus radical 21 plus 12 radical 7 plus 4 radical 3. 9 times 7 is 63 minus 3 is 60. And that is your answer. 20, I think I also have to, I don't have enough space to do 20 either. So let me do problem number 20. Radical 9x minus 2 radical x plus 7 equals 1. Okay, so let me isolate one radical on one side of my equation, the most complicated one. So I will isolate the radical 9x minus 2 on one side of my equation. So let's add radical x plus 7 to both sides of my equation. And so you get radical 9x minus 2 equals 1 plus radical x plus 7. Let me square both sides of my equation in order to get rid of the square root. And so I get 9x minus 2 is equal to, by the special product formula, it's just going to be 1 squared plus 1 times radical x plus 7 times 2 is 2 radical x plus 7 plus radical x plus 7 quantity squared, which the square gets rid of the square root, so you just get x plus 7. Combining like terms, I get x plus 7 plus 1 is x plus 8 plus your remaining terms. X plus 7. Let me subtract x 8 from both sides of my equation. And so you get 8x minus 10 equals 2 radical x plus 7. Divide both sides of your equation by 2, so you get 4x minus 5 equals radical x plus 7. And so now I can square both sides of my equation to get rid of the square root. And so I get 16, but again, the special product formula. 4x quantity squared is 16x squared. 4x times negative 5 is negative 20x times 2, negative 40x. Negative 5 squared, 25, equals, well, the square gets rid of the square root, so x plus 7. Subtract x 7 from both sides of your equation. And so I get 16x squared minus 41x plus 18 is 0. And I can try to factor that. This factors into 16x minus 9. X minus 2 is 0. Let me try to insert another page. Good. So let me set each factor to 0 and solve for x. Add 9 to both sides of my equation. Divide by 16. So x is equal to 9 over 16. Add 2 to both sides of your equation. So x is equal to 2. And lastly, let's check. So let's check x equal 9 over 16. And so let's plug into the original equation here. So, and I guess I'll just say C below. C below. Okay, so 9x minus 2x plus 7. So the square root of 9x plus 2 that's got to be a minus 2 minus x plus 7. Is that equal to 1? Okay, good. And so this is the same as the square root of 9 times, so I can write this as 9 over 1. So 9 times 9 is 81 over 16. I can get a common denominator, so I can multiply and divide this term by 16. 32 over 16 minus the square root of, again, let me get a common denominator. So let me multiply and divide by 16. And so 9 over 16 plus 112 over 16. And so I get 81 minus 32, 49 over 16. Next, 9 plus 112, 121 over 16. Is that equal to 1? So square root of 49, 7. Square root of 16, 4. Square root of 121, 11. Square root of 16, 4. Is that equal to 1? Well, no, it's equal to negative 1. And so, no, that doesn't work. Okay? Let's check when x is equal to 2. Well, let's see. Is the square root of 9x minus 2 minus x plus 7 equal to 1? Is 18 minus 2 minus square root of 9 equal to 1? Square root of 16 minus 3 equal to 1? 4 minus 3 equal 1? Yes. And so the 9 over 16 is extraneous, but x equaling 2 works. Okay, and remember that you've got to check or else you will not get full credit. Okay, so let me do problem number 21. And so I to the negative 18 is the same as 1 over I to the 18. Well, 18 divided by 4 is 16 with the is 4 with the remainder of 2. I to the fourth is 1. So this is 1 over I squared, which is negative 1. And so your answer is negative 1. Let me write radical negative 3 minus 2 in standard form. So let's write the negative 2 first, plus the square root of negative 3 is just I rad 3. The real part is negative 2. The imaginary part is the radical 3. And that is your answer. Perform the indicated operations. 3 plus I. Now let's change all the signs inside the parentheses. Minus 2 minus 4I. Combine like terms. 3 minus 2 is 1. 1I minus 4I is minus 3I. And that is your answer. Let me do problem 24. Multiply. Well, this is a special product formula. The product of the sum and difference of two terms. And so 9 times 9, 81. 6I times negative 6I, negative 36I squared. But I squared is negative 1. Negative times negative becomes positive. So this just becomes 81 plus 36, which is equal to 117. And that is your answer. Let me do problem number 25. And so multiply z times its conjugate. And so the conjugate is just the same number, except I'm going to change the negative 4i to a positive 4i. So just like above, using the special product formula, I get a negative 8 times negative 8, 64. Negative 4i times positive 4i, 16i squared, negative 16i squared. Again, I squared is negative 1, 64 plus 16 is equal to 80. And that is your answer. Rewrite. So let me multiply and divide by 5 minus 7i, the conjugate of the denominator. in order to get rid of the I in the denominator. And so you get 45I minus 63I squared, 25 minus 49I squared. I squared is negative 1, so minus the negative 63I squared is a positive 63. I squared is negative 1, so the negative 49I squared becomes a positive 49I squared. And so you just get 25 plus 49, which is just 74. And that's your answer. Okay. Let me do problem 27. Yeah, I think I have enough space. Yeah. Okay, so you have a right triangle with legs 12 and 16 centimeters. You want to determine the hypotenuse. So by Pythagorean's theorem, a squared plus b squared equals c squared. So 12 squared plus 16 squared is x squared. 12 squared, 144. 16 squared, 256. So x squared is 400. So x is equal to plus or minus the square, plus or minus 20. Of course, it doesn't make sense to have it as negative 20. So your answer is 20. Let me do problem. Darn, I just barely have enough room for that. It's going to be a little squeezed. The perimeter of a hall is 14 meters. The length is 4 meters. Don't know, maybe I'll call it X. I don't know the width. I want to determine the diagonal. Maybe I'll call it Y. So, I have here, well, the perimeter, 14, is just twice. I have 2. I have 4 plus x plus 4 plus x is just 2x plus 8 is 14. Subtract 8 from both sides, so 2x equals 6, so x is 3. Then by Pythagorean's theorem, I have that, I have to separate it a little bit. I have that a squared plus b squared equals c squared. And so 4 squared plus 3 squared is y squared. And so 16 plus 9 is y squared. And so y squared is 25. And so y is equal to plus or minus 5. Since it's a length, it'd just be 5. So my answer is 5 centimeters. 5 meters. 5 meters. That was centimeters. I don't know if I can write centimeters here. Yeah, probably not. I guess not. Oh, I can do it further away. There. And this is 5 meters. Okay, there. Got it. Okay. There. Use the square root property. So that says that x is equal to plus or minus the square root of 4. So x is equal to plus or minus 2. Solve the equation. So I can use the square root property. 3x minus 1 is equal to plus or minus the square root of negative 1, which is I. Add 1 to both sides of your equation. And so I have that 3x is equal to 1 plus or minus I. Divide by 3. So x is equal to 1 plus or minus I rad 3. 1 plus or minus I over 3. And that is your answer. Complete the square. So this is the same as x squared plus 6x minus 4. Since there's a 1 in front of the x squared, 6 divided by 2 is 3. 3 squared is 9. So let me add and subtract 9. And so, by the special product formula, this is just x plus 3 quantity squared minus 13. And that is your answer. So there you have completed the square. Let me do problem number 32. And so I guess I can't really factor this. So let me use the quadratic formula. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to a negative 3, negative b, plus or minus the square root of b squared minus 4ac all over 2a. And so I have that x is equal to negative 3 plus or minus the square root of 9 minus 80 over 4. So x is equal to a negative 3 plus or minus the square root of negative 71 over 4. And so the square root of a negative number will just be an I. So let me do that. So x is equal to negative 3 plus or minus I rad 71 over 4. And that is your answer. Let me do problem number 33. Oh, you could factor that if you wanted. So it says to use a quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to 6 plus or minus the square root of 36 plus 28 over 2, which is equal to, well, 36 plus 24 is 50, 64. Square root of 64 is 8. And so x is equal to 6 minus 8 over 2. negative 2 over 2, negative 1, or x is equal to 6 plus 8 over 2, 14 over 2, 7. And so I have two solutions. X is equal to negative 1, x is equal to positive 7. Let me do problem number 34. Let me subtract 5x, add 3 to both sides of my equation. And so I get 7, I get 7x squared minus 5x plus 3 is 0. And so by the quadratic formula, I have x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to 5 plus or minus the square root of 25 minus 4 times 7, 28 times 3, 84 over 14. 25 minus 84, negative 59. 14. And so the square root of a negative number will just be I times that radical 59. So 5 plus or minus I rad 59 over 14. And that is your answer. Let me do problem 35. So first off, I can factor out what's in common, x squared. And so I get x squared minus 6x plus 5 is 0. And I can factor x squared minus 6x plus 5 is x minus 5, x plus 1, x minus 1. It's a negative 5. X minus 1 equals 0. And set each factor to 0. And so I get x squared is 0. X minus 5 is 0. X minus 1 is 0. And so I get x equals 0. That's actually a double root. X equaling 5. X equaling 1. So actually the x equals 0 is actually twice. You don't need to write it twice, but really there are 1, 2, 3, 4 roots to this fourth degree equation, to this fourth degree polynomial. Let me do problem 36. This is quadratic in form. And so I can factor this. This is just factors into 2 radical x minus 1. Radical x plus 2 equals 0. And so set each factor to 0 and solve for x. And so add 1, so 2 radical x is 1, divide by 2, square, so x is 1/4. Subtract 2, square both sides of your equation, so x is 4. And now let's check. X equal 1/4. And so 2 times 1/4 plus 3 radical 1/4 minus 2, is that equal to 0? So 1/2 plus 3/2 minus 2 is indeed equal to 0. So that works. Let's check when x equals 4. Is 2 times 4 plus 3 rad 4. Oh, darn. Oh, I know what we can do. I'll do it over here, then I'll move it over there. Is 2 times 4 plus 3 rad 4 minus 2 equal to 0. So let's check that. So it's 8 plus 12 minus 2 equal to 0. Well, that's going to be no. Wait. Square root of 4 is 2. Is 8 plus 3 times 2 minus 2 equal to 0? Is 6 plus 6 equal to 0? No. And so that's not a solution. Let's see if I can cram this over here. Oops. Okay, yeah, it just crams there. Oh, is not equal to. Well, it sort of ran out the page, but there were some zeros there. And so, no, that's not, doesn't work. Okay. Oops. Okay. Solve this equation. Okay, so just barely have enough for that. Actually, what I'll do, so see below. I don't think I can cram that into this little space. Nope. Okay. Good. Okay, so let's do this. Problem number 37. I'll have more space to do it. 4x minus 1 over 2x plus 3 equal 1. So let me multiply both sides of my equation by 2x plus 3. And so if I do that, I get 8x plus 12. The 2x plus 3's cancel, so you just get minus 1 equals 2x plus 3. Oh, wait. It was 4x, not 4. So 4x times 2x plus 3 is 8x squared plus 12x. Let me subtract 2x, 3 from both sides of my equation. And so I get 8x squared plus 10x minus 4 equals 0. Actually, let me divide each of these terms by 2. So I make that a... Where's my x? And so I have 4x squared plus 5x minus 2 is 0. I guess I really can't factor this, so let me use the quadratic formula. So x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus the square root of b squared. Let me move this over a little. B squared minus 4ac all over 2a. And so I get x is equal to negative 5 plus or minus the square root of 25 plus 32 over 8. And so x is equal to negative 5 plus or minus the square root of 57 over 8. Notice that only if x were equal to negative 3 over 2 would I be dividing by 0. So I'm not dividing by 0 in either case. Therefore, both of these are solutions. Okay. Let me do problem number 38. Actually, for 38, I probably have enough room. Well, I got space on the bottom. I might as well, just in case. So let's see below. I don't want to cram it too much. So, problem number 38. Two cranes can unload a so two cranes can unload a ship together in 15 hours. The faster crane takes 16 hours less than the slower crane. If each were to unload the same ship alone, how long does it take for each crane to unload? Okay, so I guess let x be the slower crane. So let x equal the time in, was it hours? Time in hours that it takes the slower crane to unload the whole ship. The ship. Okay, so therefore it can unload, the slower crane can unload 1 over x of it per hour, whereas the faster crane takes 16 hours less. So the faster crane can do it in x minus 16 hours. So it can do 1 over x minus 16 of it per hour. And it takes a total of 15 hours if they work together. So they can do 1/15 of it per hour. Okay, so, I don't know. Maybe what I'll do is, first, I guess I'll do this. Let me multiply and divide by x minus 16. And so I get x minus 16 over x minus 16 plus x equals 1 over 15. So I get 2x minus 16 over x minus 16 equals 1 over 15. Let me cross multiply. And so if I do that, I get 2x, oops, I get 2x minus 16 times 15 equals x times x minus 16. And so let me multiply that inside the parentheses. And so I get 30x minus 240 is equal to x squared minus 16x. let me add 240, subtract 30x from both sides of my equation. And so, I guess I actually need another page. This is longer than I thought. So I get x squared minus 46x plus 240 equals 0. Oh, I can factor that. X minus 40, x minus 6 is 0. So I get x minus 40 is equal to 0, or x minus 6 equals 0. Add 40 to both sides of your equation. Add 6 to both sides of your equation. So x is equal to 40. X is equal to 6. You can't have 6 hours, because if you had 6 hours as being the slower crane, then the faster crane would be 6 minus 16, a negative 10. And so that's a contradiction. So you can't have that. You can't have it unloaded in negative 10 hours. So the other crane will load it in in x minus, I did it again, in x minus 16 hours. And so 40 minus 16, 24. And so one does it in 40 hours and the other in 24 hours. And that's your answer. And so let me do, I can do this. Let me do problem number 39. And so I have here x minus 6 times x plus 6 is less than 0. So let's determine the critical numbers. Oops. Critical numbers. Okay, and so set each factor to 0. And solve for x. So x is equal to 6. X is equal to negative 6. So I'll put those on my number line. Negative 6. Actually, maybe what I'll do is I'll just do it here. Negative 6. Positive 6. Question. Yeah, the critical numbers are just the factors of the standard form, of the right-hand side, left-hand side of the standard form. Okay, so pick a number between negative 6 and 6, let's say 0. Negative times positive is negative. Take a number greater than 6, say 7. Positive times positive is positive. Take a number less than negative 6, let's say negative 7. Negative times negative is positive. We want this to be less than 0, so let's fill in. Oh, that's a little thick. So let's fill in where it says negative, and that's your answer. And so, and we do not fill in either of these critical numbers. And so this is just the open interval from negative 6 to positive 6. And that's your answer. Okay. Let me do problem number 40. I'm not going to have enough room for that. So let me do that below. Oh, good, I have room. Okay, so problem 40. 3 over x minus 6 is greater than 1 over x plus 2. Okay, so let me solve that inequality. There's a 3 there. Yes, there is. Okay, good. So let me subtract 1 over x plus 2 from both sides of my inequality in order to write this in standard form. And so I have 3. So I have 3 over x minus 6 minus 1 over x plus 2 is greater than 0. And so let me get a common denominator. The common denominator is just x minus 6 times x plus 2. So let me multiply and divide by x plus 2 by x minus 6. And so multiply the 3 in the parentheses, the negative 1 inside the parentheses. And so I get 3x plus 6 minus x plus 6. And so let me combine like terms. So if I do that, I get 2x plus 12 over x minus 6, x plus 2 greater than 0. Let me factor what's in common. 2. What remains is x plus 6 over x minus 6, x plus 2 greater than 0. So let's determine the critical numbers. Let's set each factor to 0. Well, obviously 2 can't be 0. X plus 6, x minus 6, x plus 2. So x is equal to negative 6, positive 6, negative 2. Let me put these critical numbers on a number line. Negative 6, negative 2, positive 6. Take a number bigger than 6, 7. Positive times positive divided by positive times positive is positive. Take a number between negative 2 and 6, 0. Positive times positive divided by negative times positive, negative. Take a number between negative 6 and negative 2, let's say negative 3. Positive times positive divided by negative times negative is positive. Take a number less than negative 6, let's say negative 7. Positive times negative divided by negative times negative is negative. I want this to be greater than 0, so I'll fill in the plus and since it is still greater than 0, there's no equal sign, I will not fill in any of these critical numbers. And so this is the union of these two open intervals. And that is your answer. Okay. Let me do problem number 41. So there, I guess I have to do this above. So problem 41, which is Let's write this as a augmented system. 6, 1, -2, -2, 5, 10, 5, -4, 8, 2, -5, 10. First off, let me interchange first and say second rows. So let's interchange the first row and the second row. So I get 1, 5, -4, -5. I want to make this first term 0. So let's multiply the first row by -6. Add to the second row. Okay, so 6 minus 6 is 0. -2 minus 30 is -32. 5 plus 24 is 29. -12 minus 5. Oh, I did the wrong way. Stupid. 1 second. 30 plus 2 is 32. Okay. Next, let's make this 0 here, the -2. So let's multiply. Let's take the third row, add to it twice the first row. 2 minus 2 is 0. Oops, wait. That's a -10. 10 minus 10 is 0. 8 minus 8, that's 0. 10 minus 10, that's 0. Okay, good. So now, all I have to do to solve this is just the back substitute. So, first off, notice they say that eventually I'll have to solve for z equal 32. So let z equal, let's say, 32t. Then, let's write this last equation. -32y plus 29z, which is 32t, equals 32. Let's divide everything by -32. That'll make my life much easier. Then I won't have big numbers to deal with. And so y equal minus 29t is equal to -1. Let's add 29t to both sides of my equation. And so I get y equals 29t minus 1. And then lastly, let's figure out what x is. So x plus 5y minus 4z equals -5. Okay, so let's simplify that. So let me multiply the 5. And so I get here x plus 145. Oh, where's the t? T minus 5 minus 128 equals -5. Combine like terms, so x minus plus 17t minus 5 equals negative 5. And so let me subtract 17t, add 5. So I get x equals 5 minus 17t. And so my solution is, actually I'm almost done. My solution is so that says that my solution here is, well, x is 5 minus 17t, y is 29t minus 1, and z is 32t. So that is my one parameter family of solutions. And then notice that when t equals 1, z is 32. 5 minus 17 is a negative 12. 29 minus 1 is 28. And 32 times 1 is 32. So that's my particular solution when z is 32. Okay. Just made it. Actually, I could have just written the rest of it right above. Okay, so let me do problem 42. So there, I guess I got to see below. So let me add another page at the bottom for that one. Oops. Okay. Oops. See below. Oh, I see. I should have allowed undo new page. 49. No, I think that's correct, right? Well, whatever. Okay, let's see if I can do it this way then. It doesn't want to insert it where I want it. Okay, it keeps inserting it never where I want it. Okay, I hate you. Okay, let's do it this way. Oh, good. Okay. Sorry about this. Let me get rid of these extra pages that I didn't want. Okay, and now see below. So that's the page I want. Okay. Good. So, 42. A coffee manufacturer wants to sell coffee, so wants to make 200 pounds of a special blend by mixing 3 different types of coffee. And so let X be the amount in pounds of the $6 coffee. Yeah, $6 per pound coffee. Y be the 650. and Z be the amount in pounds of the $7 per pound coffee. Okay, so then it says we have 200 pounds. So X plus Y plus Z is 200. I guess let me call that row 1. And so they're $6 coffee, $6.50 coffee, and $7 coffee. You want to blend this so you have 200 pounds of a $6.54 per pound coffee, and wholesale expect to make the same money by selling the blend if the amount of the highest price coffee is equal to the combined amount of the other two types. So if Z, so this is R2, so R3 says that Z is equal to X plus Y. Okay, so actually let's plug that into let's plug R3 into R1. So X plus Y is Z, plus another Z is 200. So that says that 2Z is 200. And so automatically I get Z is 100. Okay, good. So I've solved that. So that makes my life easy. Next, let's plug that into X1, R1. So, actually, yeah. So I get that X plus Y plus Z is 200. So I get X plus Y is 100. Maybe I'll call that S1 or something. And then let's do R2. So I'll plug that Z for R2 also. So 6X plus 6.5Y plus 7 times 100 equals, 200 times 6.54 is 1308. And 7 times 100 is 700. Let's subtract 700 from both sides. So I get 6 X plus 6.5Y equals 608. Call that S2. So what do I subtract from it? 6S1 minus 6X minus 6Y minus 600. And let's add that. So I get 0.5Y equals 8. Divide both sides of my equation by 0.5. So Y is equal to 16. And so I can figure out, so from S1, I get X plus 16 is 100. So that says that, so subtracting 16 from both sides, I get X is 84. So that says, I guess I have, I sell 84 pounds, or mix 84 pounds at $6 per pound. The $6 per pound blend. 16 pounds. Yeah, 16 pounds at the 6, that was 650 per pound. Right? Yeah, 650 per pound. And lastly, 84. Oh, that was Z was 100. 100 pounds at that was $7 per pound. And there's your answer. Okay. Good. Oh, write the augmented matrix. Oh, that's easy. So the augmented matrix is just going to be 8, 4, -2, 5, 9, 5. And that's your answer. Write a system, and I guess I'll call them X, Y, and Z. So this would be 2x, 5y, minus 8z is 6, 5x, plus 6y, plus 9z is equal to 9, 3x minus 9y plus 7z is equal to 1, and that is your system. Okay, so let's do this. So first I want to interchange rows 1 and 3. Okay, so let's interchange rows 1 and 3. And so 1, -2, 4, 5. Next you want to take, so from the new row 2 will be row 2 minus 2 row 1. Okay, so 2 minus 2 is 0. 4 minus 4, oh, that's 0 also. 6 minus 8 is -2. 2 minus 10, -8. Lastly, you take row 3, and I'm going to do row 3 plus 3 row 1. Okay, so 3, this is the new row 3. 3 minus 3 is 0. 2 minus 6 is -4. 12 minus 2 is 10. 15 plus 6 is 21. And that is your answer. Okay. 46. I guess I'll see below. Good, I have some room there because I accidentally put that one down there. Okay, so let me do problem 46. Okay, so let S be the small pickup, L be the large pickup, and T be the large truck. Yeah, let's do that. Okay, so so this is problem 46. Okay, so 3 small pickups plus 5 large pickups plus 8 large trucks is equal to, you need 63 dressers to be delivered. So medium, 2 small pickups, 3 large pickups, and 6 trucks need to be used to deliver 41 medium dressers. Let me call this R1, R2, R3. And lastly, 1, 2, 3. One small pickup, one large pickup, and 3 large trucks. 1, 2, 3. It needed to deliver 24 large dressers. Okay. And so if you add those, you get 5. Ooh, that's easy. So why don't I do the following? Let me do R1, R2 plus R3. 2S plus S is 3S. 3L plus 2L is 5L. 6T plus 3T is 9T. 41 plus 24 is 65. Subtract from that R1. Minus 3S, minus 5L, minus 8T, minus 63. If I do that, I get T equals 2. So you can immediately just find that T is equal to 2. Next, I guess I can simplify some of these. So why don't I plug that into, well, let's say, I don't know, R2. Yeah, and then R3 probably. And so if I plug that into R2, I get 2S plus 3L plus 6T equals 41. Subtract 12 from both sides of your equation. And so I get 2S. So I get 2S plus 3L is equal to 29. Call that S1, I guess. Next, for R3, I get S plus 2L plus 3T equals 24. Subtract 12 from both sides. 6 from both sides. And so I have here S plus 2L equals 18. Call that S2. Okay. So now let me try to get rid of, let's say S. So why don't I do the following? So let me multiply by 2. So I get 2S plus 4L equals 36. And then I'll do minus S1 minus 2S minus 3L minus 29. And so I get L equals 7. And now let's figure out what S is. And so maybe I'll do S2. S2. S plus 2L equals 18. Subtract 14 from both sides. And so S is equal to 4. And so from that we get 4 small pickups, 7 large pickups, T, 2 large trucks. And that is your answer. Okay. Compute the determinant. And so that's just going to be 2 times 7 minus negative 6 times 7. 14 plus 42 is 56. And that is your answer. Let's compute the determinant for the 3 by 3 matrix. So let's repeat the first two columns. So -3, 1, -2, -3, -1, 5. So if I multiply, I get -21 plus 18 plus 40 minus 16 plus 45 minus 21. So 21's cancel. Oh, no. That's negative and positive. So you get a 20, so you get a 3, you get a 21, you get a 5, plus 40 is 45. So your answer is 45. I could have actually probably even moved it down a little bit. Yeah, maybe I'll move it over a little bit. Okay. Compute the determinant. Certainly that's going to be a lot of space. See below. Okay. I probably have enough for 50, however. Okay, so problem number 49. Okay, so 1032. So 1032. 237 minus 3 minus 6. 3 minus 6 minus 4. 1, 2, 6, 8, 2. Okay. 2, 3, 7, -3, -6, -6, 1, 2, 6, -2. Okay. Okay, I think that's right. And so let's pivot. I guess what I'll do is I'll pivot on the 1 here. Okay, so this is equal to 1, 2, -6, 1, 0, 3, 3, 2. So I'll take R3, subtract from it 3 times R1. 3 minus 3, 0. 7 minus 6, 1. 18 minus 6, 12. 6 minus 3, 3. Take R4, subtract from it 2 times R1. 2 minus 2, 0. -4 minus 3, -7. 12 minus 4, 8. -2 minus 2, -4. Okay, and so I can do a cofactor expansion on this. This is just going to equal 1 times a positive 1 times, we'll get rid of the row and column, so 3, 3, 2, 1, 12, 3, minus 7, 8, 4, plus 0, well, minus 0, plus 0, minus 0. So those don't matter. Okay, so let's compute this. So I guess I'll put these extra first two columns so I can compute this. And so I get 109 N- Oops. Ooh. Ooh. Be careful. There's a little typo there. So I get negative 144 minus 63 plus 16. Minus and minus is a plus. 84 times 2, 168. Minus 72. Minus and minus give you a plus 12. Which is equal to, that's going to give you 75, 135, 279. That's going to give you 180, 196, negative 83. Okay. Let me do problem number 50, which I can probably do here. And so let's check if 231, negative 5, 10, 1, 6, negative 1, 1, if that's non-zero or not. Let me rewrite the first two columns. So if I do that, I get 20 plus 18 plus 5 minus 60 plus 2 plus 15, 20, 40, 60 minus 60, 0. So therefore, these are collinear. And that's your answer. And so, any questions? Any questions on anything? If not, I guess that's yes questions. Not for now. Okay, if there are no other questions, I guess that's it for today. And I guess I'll see you tomorrow at the same time. And we'll start chapter 13, 14, 15. 13. Okay. Okay then. See you tomorrow. Bye. I'm going to be deleting everyone. Bye-bye. Bye. Bye. Exit. Bye.